Up to half of the Amazon rainforest could hit a tipping point by 2050 as a result of water stress, land clearance, and climate disruption, a study has shown. The paper, which is the most comprehensive to date in its analysis of the compounding impacts of local human activity and global climate change, warned that the forest has already passed a safe boundary and urged remedial action to restore degraded areas and improve the resilience of the ecosystem. Bernardo Flores of the Federal University of Santa Catarina, Brazil, the lead author on the study, said he was surprised by the results, which projected a potential shift from slow to rapid forest decline earlier than he had expected. The forest is already becoming weaker and more homogeneous, he said. By 2050, it will accelerate rapidly. We need to respond now. Once we pass the tipping point, we will lose control of how the system will behave. This requires international action, because even a local halt to deforestation would not prevent collapse without a global reduction in the CO2 emissions that are disrupting the climate. For 65 million years, Amazonian forests have withstood climatic variability, but the region is now exposed to unprecedented stress from drought, heat, fire, and land clearance, which are penetrating even the deep central areas of the biome. This is altering the functioning of the forest, which in many areas is producing less rain than before and turning a carbon sink into a carbon emitter. Concerns over an Amazon tipping point have been discussed for the past 2 decades, with previous models suggesting this could come when 20% to 25% of the forest is cleared. The new study, published in Nature on Wednesday, goes further in its complexity, analyzing evidence for 5 drivers of water stress and identifying critical thresholds that, if crossed, could trigger local, regional, or even biome-wide forest collapse. It estimated that by 2050, 10% to 47% of Amazonian forests will be exposed to compounding disturbances that may trigger unexpected ecosystem-wide transitions and have an adverse knock-on effect for regional climate change. To prevent this, the study found that a safe boundary, which includes a buffer zone, would be to keep deforestation to 10% of the Amazon region and to keep global heating within 1.5 C above pre-industrial levels. But overshoot has already happened. The study found 15% of the Amazon has already been clear and another 17% has been degraded by human activity, such as logging, fires, and under-canopy extraction. A further 38% of the Amazon may be weakened as a result of the prolonged droughts over the past decade. Using recent data collected on the ground, proxy indicators of ancient trends, and computer modeling that incorporates regional and global climate trends, the study traced 3 plausible ecosystem trajectories: a white sand savanna, a degraded open canopy, and a degraded forest, all of which would bring more fire and drought. Dry season temperatures are already higher than they were 40 years ago. By 2050, the models projected between 10 and 30 more dry days than now, and an increase in annual maximum temperatures of between 2°C and 4°C. The paper said this would expose the forest and local peoples to potentially unbearable heat and potentially reduce forest productivity and carbon storage capacity. Rainfall patterns are shifting. Since the early 1980s, swathes of the central and peripheral Amazon forest have become drier. Annual rainfall in the southern Bolivian Amazon has declined by up to 20 millimeters. By contrast, western and eastern Amazon regions are becoming wetter. If these trends continue, the paper says, ecosystem resilience will be reshaped and some regions will become savanna. This will have a profound impact on local and regional populations. The Amazon is home to more than 10% of the Earth's terrestrial biodiversity, stores 15 to 20 years worth of global CO2 emissions, contributes up to 50% of rainfall in the region, and is crucial for moisture supply across South America. Its evapotranspiration helps to cool and stabilize the world's climate. but its importance and complexity are not fully understood. The paper noted that existing computer climate models do not adequately reflect how different types of disturbances such as fire, drought, and land clearance compound one another, nor do they take into account the different effects experienced by different types of forest or the plans for new roads, such as the proposed BR 319, which would open up a huge area to illegal mining and land grabbing, or how forest degradation contributes to rain recycling, or whether the extra CO2 in the atmosphere is strengthening or weakening forest resilience. The lack of complexity in existing models can create unpleasant surprises, such as last year's devastating drought. The recent El Niño shows how everything is happening now faster than we think, Flores said. We have to expect things happening earlier than we thought. We need to address this with a very precautionary approach. We must reach net zero emissions and net zero deforestation as quickly as possible. It needs to be done now. If we lose the Amazon, it would be problematic for humanity.